Yes. Today we're going to be talking about IB physics, and this is one of the questions for the forces and Newton's chapter, which is just the basics, and it's a good foundation because a lot of the questions are surrounded around something like this. So over here we're talking about the forces which are acting on the skier. The skier is pulled up by a rope at a steady velocity. Steady velocity would mean that the tension is equal to the friction or the downward force plus downward force. So it makes an angle of 12 degrees with the horizontal. The mass of the skier is 73 kgs and the skis, and there are three forces acting on the skier. So what tip I would give you? So I'm learning this curriculum as well, but what tip I would give you, and this is what I personally do, I make a small diagram like next to the side. So where I've made one. This is a stick. It can be a simple stick figure. So it's on this. So where we're talking about the 12-degree angle. This is going to be the normal reaction force. This is going to be the friction, and this is going to be mg. Now there's going to be one other force acting. This will be the weight, which is the downward force. So we're just going to draw and label this as mg. Preferably it should be like this, same length. This is a bit like condensed, but this is what it's going to be approximately. So this is our 1 mark done. So this would save us 1 mark for our answer. Calculate the magnitude of the normal reaction force. Now this is going to be the angle. This is the normal reaction. This is the mg. So to make this, it'll be simple. This is mg. So this will be mg cos theta. Theta over here is the degree or angle. So this will be 12. So the magnitude of the normal reaction force, because the upward and the downward force, the normal reaction force in mg cos theta will be equivalent. So over here, you're going to label this mg cos theta is equal to the normal reaction force. That's why it's in equilibrium. The upward and downward force are equal. Over here, m is basically the mass. So this is 73 kgs. In most papers, g will be 9.81. And there'll be cos, and over here the degree is 12 into cos 12, and this will be equal to r. So r would be equal to, if you calculate it real quickly, it's going to be approximately 700.48, and over here we have 2 SF, so it'll be 700, and because the force is in newtons, it'll be 700 newtons. This is the SI unit. Now we'll be talking about the total frictional force acting. This again is all about the forces. We made a small diagram. Friction is here, and it's going to be, this is friction acting. Over here, the total frictional force over here is 65 newtons. So, because it's moving at a steady velocity, the total frictional force the total frictional force and mg sine theta would be equivalent to the tension. The tension is equivalent to approximately. So let's just equate this. T equals to mg sine theta plus the frictional force. The frictional force is 65 newtons. So the tension in the rope. So the tension equals to 73 into 9.81 into sine 12. Put this in the same bracket, and this will be plus F. F over here is 65, so plus 65. So the tension in the rope would be approximately 213.89, or if you want to round this up, 210, because it's going to be two significant figures. This is also this, just make sure you be careful with the significant figures because they do carry some marks. So this is 210 newtons. Now explain using Newton's first law of motion why the resultant force on the skier must be zero. Okay, over here we have Newton's first law. His first law. What does it indicate? force is the product of mass and acceleration. Because it is traveling at a steady velocity, the acceleration is equal to 0 meters per second square. So it'll just be 0. This means that when something is multiplied by 0, obviously the answer would be 0, and therefore it's in equilibrium. There are no external forces acting. So F equals to ma. Let's just say F equals to 73, and because A is 0, it'll be into 0. So the force acting will be 0. Therefore, the resultant force acting on the sphere would be 0. Okay, so this is a simple explanation. This does carry a few marks, and these are the basics. If you get the basic concepts like this, solving tough questions is not that hard. Trust me, if with a lot of practice and with a lot of like persistence, a lot of question solving, you will be able to get it. Okay, thank you guys for watching.